All right, so there are some other indeterminate forms that we can also use L'Hopital's rule with, but the trick with all of these is you have to put them in the quotient form, because in order to use the L'Hopital's rule, you need to have a fraction, okay? So the first one, as we sort of saw when my example went south there, is sometimes you have a situation where it's 0 times infinity. So for this, you just, both of these two, you're going to just simply, whatever the best you can, you're going to rewrite it as a fraction. Often, it's a situation where you can take one of the functions and turn it into a fraction, or put it in the denominator. Like, for example, I had this one similar to what we did in the end of the other example. So I have root x e to the minus x over 2, right? This is an infinity times 0. So I can rewrite it with this in the bottom. And I've got root x over e to the x over 2. And then you go ahead and just keep working. This one goes to 0. Another example, this is as x goes to 0, sine 5x cosecant 3x, okay? Cosecant, of course, is 1 over sine, right? So if I'm going to 0, cosecant is going to be infinity and sine is going to be 0. So this is 0 times infinity. But it's very easy if you think, okay, cosecant is 1 over sine. So then you just rewrite this as limit as x goes to 0 of sine 5x over sine 3x, right? Now this is in the form 0 over 0. You take the derivative, you see this one's going to go to 5/3. So this one should go to 0, this one to 5/3. All right, so those, we can probably go back and do those in a minute, but I wanted to sort of take just sort of like a whole overview. Infinity minus infinity. So these, again, to rewrite as a fraction, which is exactly what we want to do, most of the time, these are going to be fractions already. They're just two fractions that are both going to infinity. So if possible, make a common denominator. Okay. So an example that I have that looks like, now, we'll talk about this in a minute. I'll just put that on the bottom. Just rewrite it. So here, limit as x goes to 1 of x over x minus, this is a very standard kind of example. Okay, so as x goes to 1, this is going to be, of course, 1 over 0, so this one's going to go to infinity, and this one's going to go to 1 over 0, so also going to infinity. So these are like two different functions that both have an asymptote at x equals 1. So we can go ahead and work that out. And I think probably I need to be going, yeah, that's fine. All right. So the last one here, which I had written up on the board, I just wanted to mention in passing, because just so you at least sort of know that it is an issue, right? So these are indeterminate powers, something of the form, say, 0 to 0, infinity to 0, or 1 to infinity. So kind of maybe something like limit as x goes to 0 of x to the x. Okay? We should probably have this as plus. Okay. I'm not going to do these. That's going to be extra material because this is not going to appear on test or a quiz, and it's not on the web assign If it is on the web sign, I'll fix it because it's not supposed to be on the web sign. All right, so these, you kind of do the same thing though. You want to rewrite it as a fraction. Really, you want to get it out of this form. So you first write it as a logarithm, right? So if I have x to the x, so I'm just going to talk about it real briefly here. I can write e to the natural log of the whole thing, right? X to the x. So then this is e to the x natural log of x. But now I sort of have this weird thing that I have to deal with. And then you do a little trick, which you can do for limits sometimes. You say, okay, we're going to assume that this limit is a finite number and it's L. Big L. Now you take the log of both sides. That'll kill this. And then you have something, in this case, you have something of this form, and then you have to do this. And then eventually you can back out an answer. So these, I'm not going to give you these. Only in the extra materials. If you want to see some of them worked out, they're worked out there. But just so that you know, in case later on in your experience in calc, you end up faced with a limit like this, maybe you'll remember, oh, it's something about L'Hopital's rule, and I have to write it with a logarithm and something. I need to go back and look it up then. All right, so these, we're not doing those. Just for time purposes. Okay, so let's go back. Since we're here, let's just do this one. Okay. So if I make a common denominator here, right, the common denominator is going to be x minus 1 times natural log of x. And what would I end up with in the top? I've got x natural log of x minus x plus 1, right? Because it would be x minus 1 and a minus there. So again, if I put in 1 now, this is 0. So let's just double check. It's going to be 0 minus 1 plus 1, and in the bottom, it's going to be 0 times 0. So this is definitely a 0 over 0 situation. So I can use L'Hopital's rule. It's a little bit messier, right? This isn't great. Because both of these, like that top part, I have to do some product rules. It's not terrible. Here, and then I end up with x minus 1 times 1 over x plus natural log of x. So what do I have? I have to mess around with this a little bit. So this is just going to be 1 and minus 1, so I'm going to have natural log of x in the top. What do I have in the bottom here? I have 1 minus 1 over x plus natural log of x. Okay, so natural log of 1 is 0. So I've got 0, I've still got 0 over 0, right? Because I've got 0 over 1 minus 1 plus 0. So this is still 0 over 0. So I have to do it again. But it's not terrible. Looks like maybe I'll have to do it one more time. So 1 over x in the top. This is like minus x to the minus 1. So it would be minus and minus plus x to the minus 2. And then plus 1 over x. Oh, what's this? I'm running out of space. Okay, so this looks like limit as x goes to 1. If I of a 1 over x plus 1 plus x over x squared. So, okay, I'm just going to move this up here because no one can see that. Sorry, guys. This video went the wrong way. Yeah, we'll just do these another time. Those are not too hard. Once you have it set up, you guys can do those by yourselves. This video is getting too long. So what I have, let me rewrite it. once I made my common denominator, took the derivative twice. Now, when cleaning that up, it looks like I have x squared in the top and x times 1 plus x in the bottom. And now if I put in 1, then I'm not going to get 0 anymore. Thank goodness I have 1 over 1 times 2, so I end up with a beautiful 1/2. Yay! Assuming I did this right, which I think I'm good there. All right. That's good enough.